Alright, so this is my Sprint 7 report. I'm going to go through how I've changed the rendering pipeline and how I use that to implement a splat map shader and some other shaders. To start, we're going to go over what the rendering pipeline was or is in the background still. So if you're really familiar with that, you can just skip ahead for a while. But if you're not, let's go. So on a drawable, when you do draw, majority of the time that calls render on the so we've got graphics object up here, and then the 3 built-in graphics objects, and then over here we have the render material, the 3 built-in render materials, and the render manager, which holds instances of the 3 built-in render materials. Okay. So when you call draw on a drawable, it usually calls render on the graphics object. So what does that do? Render on the graphics object calls process on prender. So what is prender? Prender is a render material, usually an instance, or always an instance of one of these guys. So process calls state and then draw on the render material. So let's look at flat texture. No, let's look at color, no texture. State. What does state do? State gets all your uniforms and passes that into use stock shader. And where is that? That is in GL Shader Manager. So it's taking variable arguments and then an enum to figure out which one it is. So it starts up the variable arguments. This is your first OpenGL call. It throws in the shader ID number, which is the compiled shader number, which I'll come back to. And then in here we've got a big switch statement, which is just great, with all the different types of shaders you could do, built-in shaders. So let's see, where were we? We were on flat. Yeah, so flat. So we pass in MVP matrix and vcolor, and those are our uniforms. And then if we try to find the source up here, MVP matrix is a uniform for the vert shader, and vcolor is a uniform for the fragment shader. Okay, so back to here. So we called state, and then we called draw. So you get your vertex object array, and then you draw all your elements with all your triangles, blah blah blah. Okay. So that pipeline went like this. Had your graphics object called render, and that called process over here, and that called state and draw down here. Meanwhile, to even get to this these render materials, let's take a look at a graphics object, the flat texture. To even get to that render material, it has to look it up in the render manager. It's passing in an enum, and what does it do with that enum? Oh, the render manager owns a specific instance of every type of render material. So they're almost like singletons, kind of, maybe? But they don't need any state data. They get passed in all their state data. They get a graphics object, they have to cast it to the exact type that they're associated with, and they pull their data off of it. There's no state data in the render material. Actually, I can probably prove it. The render type, which is the enum, which is what was used to look it up. Okay, so I thought that was all dumb. Oh, and the other thing that makes everything difficult is let's see if we can find. We still have no. If we go back to the GL Shader Manager. So initialize stock shaders. So this is where it's compiling all the shaders. And it's from the source up here, all these C strings. and it compiles them, and it throws them in this array based on these enums, which is a way to do it. Alright, so that's the stock shaders. What I've done is I wrote a graphics object custom shader. Can't tell in here, but it's a subclass of graphics object. The class diagram didn't let me put this in here for some reason. But it's a subclass of graphics object, and it's templated. I'll try to explain that later. And then down here, you make your specific, oh, I'm doing a splat map shader, I'm doing a checkerboard shader, I'm doing whatever. And this custom shader has a bunch of built-in functions to make passing in variables easier and centralizes everything. So let's look at, let's start here. Oh, and it's a template, so it's on the header. Okay, great. Alright, this is not going to make sense. Okay, well, yeah, let's start here. So we'll start up here. The template is the curiously recurring templating design pattern where the subclasses will be templated to themselves. So graphics object splat map, public custom shader, graphics object splat map. And the reason you do that is so that you can call stuff on the subclass. And in order to do that, you have to make it a friend class. And the reason I did that is so I can enforce certain behaviors that I couldn't quite do through normal object-oriented methods. So every shader has this shader ID, which in the GL shader manager was stored in that array. For a custom shader, it's just stored as a static variable on the class. But I can't enforce that the subclass has a static variable because it can't be static virtual, because that just doesn't make sense. So I'm enforcing it by through the templating calling shader ID on subclass. So if they don't have a static variable named shader ID, it will not work. It will not compile. So that's the point of the curiously recurring templating. Let's see. Where does that shader ID come from? So if we go into an example, so the splat map initialize. The initialize method is another one where I can't quite enforce that they have it, again because it's a static method. But you basically have to have it in order for your shader to work at all. And it's of this form of, it just sets your shader ID to loading it in the compiled location, whatever you get. So this is what was happening in that load stock shaders in GL Shader Manager. So that's what sets up shader ID. I wrapped up a create method so that it's added to the graphics object maker, and that way you don't have to write a new function on the graphics object maker every time that you make a new shader. So on the user end it looks like this: set graphics object custom shader. You have to do the templating so that it knows what the template variable is. Create, and these are the exact same parameters as the constructor. And I'm doing that through variable arguments, and then I'm passing, or variable template arguments, and then I'm passing those to the constructor of subclass, and that's why you need to pass the template variable. This is a C++ 11 feature, and you need to install a certain file from Microsoft to get this in Visual Studio 2012, and I'll make sure that there's a link to that also in the folder for this week. And then once it's just one file you need to install, and then it'll work. And the reason I thought it was worth it to do that is so that I can make this create method, and it's super easy, and it makes sure that the memory is still managed correctly. And then the user doesn't have to write their own create method every time they make a shader. Okay, the constructor for the custom shader just checks that shader ID, makes sure it's not this uninitialized value, which the user still has to set it as that. So when they, again, because I can't enforce this, when they initialize their shader ID, it'd be nice if they put it to this uninitialized shader ID value. And it's 0 if the shader doesn't compile. So let's look at the render is the same, except for I've moved the GLUse program call out to before state. The order doesn't quite matter with the way that these run. State is basically the same. Draw, I've actually defined down here somewhere. It's virtual, so you can override it, but I gave it this, which is just the draw the triangles and make sure that they have faces on them. So like the wireframe is different than this, but nearly everything else is the exact same thing as this. So then you don't have to rewrite this every time. Whereas your state is definitely going to be different every time. Let's just finish this off. And then in the middle here, I have a bunch of nice wrapper methods to pass uniforms in. So passing a vector, passing a matrix, passing an int, passing an array. But it's just this like, it's boilerplate code that you'd have to copy paste all the time. And now it's all wrapped up. And then a nice generating an array where it's just, or no, this is binding the textures and this is generating the array for the samplers. So, and then a camera thing. So just nice wrapper methods. Okay. So this render state draw structure is still the same, but instead of render calling state and draw on a render material, it calls state and draw on itself. So let's see what, for our splat map, what would state be? State binds an array of textures, which, so like when you construct your splat map, you pass in all your textures, and then they get set into this array. And then it's like an int, and then this generates the sampler array, which is just like 1, 2, 3, 4, 5. And then down here, we pass those all in as uniforms through those nice wrapper methods. Okay. I think that was everything. The source is still these C strings up at the top, just like GL Shader Manager, which is alright. It was annoying to, cause like when you add a line, you have to be like, oh, okay, make sure I'm tabbed over, okay, write my stuff, and then finish off, and make sure you don't put a semicolon there, which just got kind of annoying. So I'm thinking of adding a feature to read in a text file, so you don't have to screw with all this garbage. Even though it might add some overhead on startup to load in those files, that might be a little slower, but it might be worth it just to get rid of the headaches. Alright, I think I covered everything. So the source is still up here, and then in your initialize, you pass those in, just like how it works in GL Shader Manager. Okay. Alright, so first let's see. Oh, I hope this compiles. Did I not build this? Well, that's built. Alright, so the splat map, again, so it's taking in a model just like everything, a texture for the splat map, no number of UV repeats, and then 4 textures. The last 2 are optional. Oh, here we go. I think it's running. Okay.